Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll show the machining of a large complex part using HSR and HSM. Now, note that this is a relatively large part, approximately 500 millimeters in either direction, and the geometry on top is actually pretty complex, with we're being partially exposed upwards, and we have a partial cavity inside here as well. So first, we'll actually open up our first operation that we've done here, and we'll be using HM roughing. The tool in this particular case will be a 30 millimeter end mill, and our boundaries will be around the entire part. In our passes, we'll be leaving a wall offset of 0.5 millimeter and stepping down every 5 millimeters. And in our HM roughing, we'll be using the option of HM spiral. Let's take a look at the simulation itself. And as you can see in the simulation, and I'll run this relatively slow, you can see that the part is being machined from the outside in, making for the most efficient type of a tool path you can use on a part such as this. Let's actually stop this, and we'll use the option of Quick Solid Verify, and you'll see that the part is being machined from the outside in, machining every single area that needs to be machined on the part. Okay, now in this particular case, I would like to point out that if I were to go into my settings, you'll note that my update stock calculation, I'll be using the special for HSR and HSM, since all of my operations are HSR and HSM operations. Now, if I were to go into my next operation, we have the rest rough operation. This is based on my previous operation, and this time I'll be using a 16 millimeter ball nose end mill. Now, my constraint boundaries, I've actually created a boundary around this edge over here. As this flat area, I'm just going to machine later on using horizontal machining for that area. But this area, I just like to work in this area only for my rest roughing. Again, I have my passes using my same wall offset, and I have my step down. Now, since I'm using the option of updated stock of HSR and HSM, if I go into my edit passes, you'll note that it's going exactly according to the HSR operation. If I were to run my calculation, you'll see that's actually calculating very quickly on the part itself, not having to update the stock at all. It's actually just looking at this operation, and automatically within this window, it does the calculation for the updated stock as well, making it work a lot quicker. As you can see, the calculation has ended very quickly, and if I run my simulation, you'll see that the tool is working only in these areas and doing exactly what it needs to do for the rest rough operation in this particular case. Now, I can stop my simulation right now, and instead of looking at my tool path that way, I can go out and simply click on the checkbox over here. It'll actually pop up immediately, since this toolpath simulation is automatically calculated also as well during the calculation itself. Now, in our next operation, I'd like to do an HSM operation just for doing a semi-finish on these corners over here. So if I were to go into that operation that I've created over here, I'll be using what we call parallel pencil milling. This is actually a very simple but powerful tool to use for those types of corners. I'll be using a ball nose end mill in this particular case, and my constraint boundaries will be just as in my previous operation, around this area over here. My pencil passes, I'll have a wall offset of 0.3 millimeters, and if I go to my passes, you'll note that I'll be having a horizontal step over and step down of 0.2 millimeters, but I'm limiting my steps to only 10 times. Now, if I were to run my simulation over here, you'll note this time that the tool is working exactly on those edges as shown over here, exactly within that area. Again, let me just stop this now, and well, instead of running the simulation, I'm just going to click on the checkbox over here so we can see the actual toolpath that's created. As you can see, if I zoom into these areas, you can see the nice, perfect toolpath that we're getting around all of the edges that I want to the machine. Now, being that there's a whole complex area over here, I'd actually like to get a nice toolpath that takes care of this entire area over here. So for that, I've actually used the option of 3D constant step over. I'll be using the same boundaries as I did before, as shown over here, around over here, and I'll be using that as my drive boundaries and as my constraint boundaries as well. In my passes, I'll be stepping over every millimeter, and since this is a semi-finish operation, I'll be working again at 0.3 millimeter offset from the floor and the wall. Now, I've also gone into my link in this particular case, and I've chosen to choose the option from first pass, working from the outside in. If I were to run my simulation in this particular case, you'll see that the tool is actually working from the outside going in towards the middle itself. Again, you can see that really nice toolpath working around the part, very evenly on the surfaces itself. Let me actually stop this again, and I'll actually go out and again show you the toolpath just by clicking on this area over here. You can see we get that really nice toolpath evenly placed around that entire area, whether it be the part that's sticking out or the cavity that's inside over there. Now, one more option I'd like to show you over here is something with working on colored areas, filtering out by using a color. I'd like to do a finish cut on these surfaces as shown over here. So I'm going into the operation, and I'll be using the option of 3D constant step over. I have my tool, and I have my drive boundaries. In this particular case, I'm going to create a drive boundary, and the drive boundary is going to be created in the following way. I'm using selected faces, and if I go into my drive faces, we've added the option now in HSM to choose by color. Now I can either define the color or simply pick the color from the model. Note what happens over here when I pick the color from the model. I'll click and click on the surface itself. You'll note that it automatically picked up that color. Now when I click on Find Faces, it found all 4 of those faces that I want to the machine simply by recognizing its color. I'll accept that. And then I'll click on OK to create the actual boundary around the part. Now, in my constraint boundaries, I'm going to do the exact same thing. I'm just going to choose that boundary that I created and use the exact same settings over here. In my passes, I'm going to have a horizontal and vertical step over of 1 millimeter. And in my links, this time I'm going to leave it without checking off from first pass, as I want it to work from the middle out. Let's run my simulation. And as you can see, we have the toolpath working from the inside out on each surface. And you'll note we have that one area going in and one retract from the entire part. Always having a really nice, smooth finish on all of these surfaces as shown over here, with no extra jumps to the clearance area. All is working exactly on the surface. You can also note that the links between each passes are done very smoothly, radiusing out of the toolpath and always radiusing into the following toolpath as well. Now, one last thing I'd like to mention is the issue of tolerances over here and the issue of point reduction as well. We've actually made it a lot easier to understand what the tolerances actually do. Note when I click on the tolerance, we can see the actual diagram showing exactly what the tolerance does. By making the tolerance higher and lower, you can actually see the type of tool path that we're going to be getting, a tighter fit or a looser fit as shown over here. So it's a lot easier now to understand exactly what the tolerance does. We've also added it as a slider, making it a lot easier to choose from the different options over here. If you need to change your tolerances without being between these two areas over here, you can simply just open up the entire tolerance area and write any value that you want over here, whether it be 0.015 or whatever value you want to have over there. Going back over here, we keep the values that are in over here as well. Now, we've also made it easier to understand the point reduction as well. Just by simply changing this, we are reducing the number of points. This is important for when you do not have too much room on your machine for a large G code. Now, the larger the G code, the smoother the toolpath you'll get. But you can also do a point reduction so you'll have less points to calculate to create the G code as well. Now, we'd like to actually make a little bit of a recommendation. If you need a very good surface finish on parts, we'd recommend not to use the option of fit arcs. Fit arcs actually puts a lot of G2s and G3s into your calculation of parts, but also it'll give you not always the best surface finishes over here, as you can see in the point reduction that it's doing over here as well. This will give you a nice one, but not as nice as using it without the fit arcs. Now, if you are not limited at all with the amount of points you need in your G code, we recommend working without the fit arcs. And if you want, you can go into tolerance and put a tolerance of 0. This will actually give you a very smooth finish on the part itself. Again, this is specifically recommended for parts where you do not have a limit of the size of your G code. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.